Okay, good day. For this session, we'll discuss about the shape of the Earth. Is it round, spherical, plane, or disc? It is about the history of the proposed shape of the Earth. Around 500 BC, Pythagoras and his pupils proposed that Earth was round. And after that, Anaxagoras, around 430 BCE, he conducted observations that supported Pythagoras' proposal. He observed that during lunar eclipse, the Earth was the Earth's shadow was reflected on the moon's surface. The shadow was circular. So that's how Anaxagoras supported Pythagoras' idea. So next, later on, Aristotle, around 340 BCE, listed several arguments for a spherical Earth, which included the shape of the moon and the sun, the positions of the North Star, and the disappearance of the ships when they sailed over the horizon. Because Aristotle observed that ships, when they are far away from the shore, they tend to disappear over the horizon. That's how Aristotle proves that Earth is spherical. Aside from that, he also observed the shape of the moon and the sun, the positions of the North Star. Okay, according to Aristotle, around 340 BCE, Aristotle argued that if the moon and the sun were both spherical, perhaps Earth was also spherical. The North Star was believed to be at a fixed position. However, when the Greeks traveled to places near the equator like Egypt, they noticed that the North Star is closer to the horizon. Aristotle argued that such an observation is only possible if Earth was round. So, for example, Egypt is nearer in the equator, while Greeks, their original position as they observed the North Star, their initial position is closer to the North Pole. Okay, so the North Star is observed as further away from the sky, from the Earth. Yes, and then when they traveled places near the equator, the North Star seems to be bigger or nearer. That's how they supported the idea that Earth was round. Again, if the Earth was flat, then the ship traveling away from an observer should become smaller and smaller until it disappeared. However, the Greeks observed that when the ship sailed, the hull disappeared first, which implied that the surface of the Earth was curved. That's how they observed that the Earth was curved. So imagine a horizontal displacement. So when the observer is uh, far away from the object, it will only shrink or become smaller. Unlike when the Earth was curved, so it tend to lower down until its disappearance. It's like hiding from a hill, like that. So according to Eratosthenes, he attempted to measure the circumference of the Earth. He received correspondence from Syene in southern Egypt. It stated that a vertical object did not cast any shadow, and noontime during summer solstice. According to him, the angle that the sun made with the vertical direction by measuring the shadow that a vertical stick cast, he found out that in Alexandria, the sun makes an angle of 7.2 degrees from the vertical, whereas saying the sun makes an angle of 0 degrees To explain the difference, he hypothesized that the light rays coming from the sun were parallel, and the Earth's curve. Okay, so that's how he explained the direction of the shadow from the stick. As he, I believe, as I read from the books, Eratosthenes um, measured the circumference of the Earth by traveling, by walking. Okay. From his measurements, Eratosthenes computed the circumference of the Earth to be approximately 250,000 stadia or 46,250 kilometers. Okay, to convert that, one stadia is equal to 185 meters. Okay, so that's how he measured theoretically. And that's the end of our discussion. Thank you for listening.